Hi guys, I'm sorry I couldn't make class today. Something came up, so I am going to record Chapter 20's lecture for you. A couple of reminders first. Don't forget that carbon footprints are due today by midnight in the Dropbox. Don't forget that on Monday both your Nature Connection blog posts are due and also your reflection is due. And then we have our final exam on Wednesday, and we're going to take Monday's lecture to cover, Monday's lab period to cover the lecture material. Okay, so air pollution. There are millions dying around the world due to air pollution, and any quick Google search you will find many examples of where people are suffering from air pollution and trying to find ways to solve the problem of air pollution. In California, there is two cities in California that are famous for their air pollution. One is Bakersfield, which has issues with particulate pollution, and then also Fresno, California, which has issues with ozone air pollution in particular. And we are going to be covering exactly what those are later in this lecture. Here's just a quick Google search that's current for air pollution. They actually have linked crime to air pollution in London. And they are constantly monitoring and reporting on where the cities are in the world that have the worst air pollution. Okay, so we're going to cover what outdoor and indoor air pollution are. We're going to cover all the different impacts that air pollution has on us, including health, economic, and ecological consequences. Then we'll talk about secondary effects of air pollution that you may not even think of as air pollution, such as acid deposition. And then we'll talk about how we can reduce air pollution. So every year about 3 million people die prematurely due to exposure to air pollution. If you look at this map from your textbook, it shows you that the most deaths from outdoor air pollution happened in Russia in 2008. That is not because Russia has the worst air pollution in the world, but I suspect that is to do with their medical capacity to handle the effects of air pollution. I looked up another map, and I found that this map from 2016 shows that while Russia is still one of the highest, along with the United States, in the number of deaths from outdoor air pollution, Southeast Asia in 2016 ranked to be the highest of deaths that were due to outdoor air pollution. So if you had to define air pollution, the correct answer is any dangerous or unwanted material that is released naturally or by humans into the air. So it doesn't just have to be something that's caused by humans. A is not correct because it's not necessarily just released by humans. C is not correct because it does not necessarily have to be converted into a dangerous form. And D is not correct because it's not just that human health is impaired, it can also affect plants and animals and any species in the ecosystem. This chart shows the deaths attributed to both outdoor and indoor air pollution. So the last map that we looked at was only for outdoor air pollution. This one includes indoor air pollution. Indoor air pollution is actually more significant than outdoor air pollution when it comes to the number of deaths that are being caused by it. In Southeast Asia in particular, you can see that there's, I don't know, more than a third, almost a half of those deaths are due to indoor air pollution. In Africa, there are more deaths due to indoor air pollution by quite a bit. And that's just the opposite then for the high-income countries. Later on we're going to talk about exactly how does air pollution affect your cardiovascular system, considering that air pollution does actually get into your bloodstream and can affect you in many ways that are not readily apparent. If you look at Delhi, India, they have the PM stands for particulate matter. Those are the particles that float around in the air. It's usually above 300 parts per million. And one of the ways that they are trying to deal with this air pollution is actually it depends on your license plate. If your license plate number is an odd number, then you can only drive on certain days, and if it's an even number, you can drive on the other days. And this is the way that they're trying to reduce the amount of traffic on their city streets. In China, their sales of electric vehicles have just surged since 2014. While the United States, in this graph shows that we've continued on increasing, but at a relatively even keel pace. China, if you've read up on it, they are releasing massive numbers of buses every year. They're trying to completely change over their bus fleet to electric. And you might say, well, wait a minute, doesn't electric mostly come from coal-fired power plants? Well, yeah, some of it does, but remember China does have a lot of solar, wind, and especially hydropower in their country. They're way ahead of the United States when it comes to renewable energy sources. Okay, outdoor air pollution. If we go back in history, in the 1930s, there was an incident in Belgium which caused 63 people to die. The reason this happened is because of a weather pattern called a temperature inversion, which trapped these pollutants inside the city and ended up sickening these people and causing 63 people to die. But a really famous incident, and there was several European incidents. I'm just capitalizing on some of these major incidents. But in 1952 in England, there had been they call it the London fog. But again, this was a temperature inversion, and there were acid aerosols. Aerosol is just any particulate matter that is floating around into the air. In this case, 4,000 people were killed by air pollution. In 1984, there was an unusual incident where an industry which was producing a gas called methyl isocyanate, there was a safety valve that was left off, and this was a mistake made by the workers, and the release of this gas killed thousands of people. And there's a lot of news documentaries on this, and it shows people suffering tremendously from this gas, and many of them died a very slow death. And this was an industry from the United States. And as I said before, indoor air pollution actually it's attributed to more deaths than outdoor air pollution. So this last point shows you that 2 million or more premature deaths happen due to indoor air pollution versus only 1.3 million deaths annually for outdoor air pollution. So this chapter reviews asthma, and talks about how asthma is, and many of you may know people who have asthma, or you may have asthma yourself. It's the inflammation and constriction of the narrow airways of the lungs. It's said to be the leading cause of school absences, and its prevalence has been increasing. It's actually doubled since 1980 to the mid-1990s, and they say that there's 7 million children and 17.5 million adults that are diagnosed in the United States with asthma. So what causes asthma? Well, it is linked to particulate matter, the small particles in the air, and nitrogen dioxide. Where does nitrogen dioxide primarily come from? It comes from burning fossil fuels. About 80% of nitrogen dioxide in the cities comes from vehicle exhaust. And what do you think the largest source of outdoor air pollution is overall? It is fossil fuel combustion. Breaking it down, vehicle exhaust, industry emissions, coal-fired power plants, and also consider the indoor burning of solid fuels. That can be anything: charcoal, wood, animal waste, anything that might put particulate materials into the air and other gases. And then, of course, there's also natural sources of air pollution that we have to consider, such as sandstorms and volcanic eruptions, wildfire. I'm sure you've heard of the Dust Bowl from the 1930s in the United States. There was a type of dust pneumonia that was caused from the Dust Bowl, that people would die a very slow, long death due to being exposed to the dust. Okay, the primary air pollutants are ones that are directly released in the air, but then there's also secondary air pollutants, and this is when a primary air pollutant reacts with another chemical, or with water, or with even the sunlight, and forms another compound. So, for example, there's something called volatile organic compounds, or VOCs. We'll talk about those later. But also nitrogen dioxide. If they react with sunlight, they actually form ground level ozone. And then also we have the release of sulfur compounds and also nitrous oxide that react with water and form acid rain. So looking at the sources of pollution, we have the stationary sources. So this would be mainly from our industries, from humans. We have the primary pollutants. We'll talk more about these specific ones, but we have sulfur dioxide, nitrogen monoxide or dioxide, carbon monoxide, carbon dioxide, and particulate matter. And again, we will talk about all of these, the effects of these specific gases when we later on in this lecture. But then many of these same things come from mobile sources. Most of this is coming from burning fossil fuels and the conditions in which the fossil fuels are being burned. So it depends on the amount of oxygen that's available, it depends on the heat at which they're burned, it depends on how much air pollution control technology is installed. So it depends on a lot of things. Then we have agriculture and mining. Again, a lot of fossil fuels are being used, a lot of particulate matter is put in the air, it's a lot of these same primary pollutants. And again, these are all anthropogenic sources of air pollution. But then we look at the natural sources, like I said before, volcanoes and dust storms. There are, of course, natural sources of air pollution too. And forest and grass fires are also natural, although one must think, well, how much of this is actually caused by humans? Dust storms are in relation to human agriculture with cultivation of the land. And then grass fires and forest fires, the intensity of wildfires is also linked to humans. So some of this is natural, some of this is anthropogenic. Then to remember that we have the secondary pollutants. So this would include ground level ozone, and then sulfuric and nitric acid are the two acids that are that cause acid rain. And then you have to think about, here's the troposphere, but then you have the stratosphere, and remember that these pollutants don't just stay in one spot. They may go to affect somebody else somewhere else in the world. Back in the old days, they thought, oh, we'll just build the smokestacks higher, so we'll just we'll get the pollution out of our city. But it didn't work out that way. After a while, they realized that they were just sending their air pollution onto a different community to deal with. Okay, hopefully for this question you answered all of the above, that air pollution is linked with respiratory illnesses. It's also linked with stratospheric ozone depletion, and it also linked to the structural damage on statues and bridges, all of the above. A, B, and C. Okay, so air pollution causes health problems, it damages structures, it causes visibility reduction, which can secondarily lead to vehicle accidents. And it also contributes to stratospheric ozone depletion and climate change. And keep in mind that ozone depletion and climate change are two separate issues, but they're caused by two different gases, which we will, well, they're caused by some of the same gases. We will get into what causes ozone depletion in the next chapters. Which of the activities contribute to the formation of acid rain? Well, anything that burns fossil fuels is going to contribute to acid rain. So you should have answered A and B. It's not grass or forest fires. Acid rain is formed by the release of sulfur compounds and nitrogen compounds into the air to form sulfuric acid and nitric acid. So acid deposition is considered a secondary pollutant because, again, the nitrogen and sulfur compounds have to react with water to form acid rain. And they call this also transboundary pollution, and the fact that it is crossing from a gaseous state to a liquid state. And it also travels long distances. Okay, for the causes, they show here in the figure that the sulfur dioxide and nitrous oxide compounds, nitrogen oxide compounds, they can be deposited dry on the ground, and they can affect the pickup of nutrients by plants by binding up aluminum in the soil. So it prevents the ability for plants to survive because they're unable to pick up nutrients from the ground. Then we have the wet deposition, and entire lakes have been known to be killed due to acid rain. And we also have to consider that the fog that is containing, so fog is basically the moisture that's in the air. If it is surrounding the foliage on trees and plants, it will eventually affect those plants. The acid will burn out the green material. Okay, and then also how it dissolves famous statues and bridges around the world. What's some good news we have, that we have done a nice job of controlling air pollution that causes acid rain. If you look at acid rain deposition in 1994 compared to 2009, you can see that we have greatly reduced it. And part of this reason is because we have better technology that's installed in our smokestacks, which I will give you an example of that at the end of this lecture. Okay. Particulate pollution, or particulate matter, they abbreviate this with PM. They say that the smaller the particles, the more harmful they are, and this is because the smaller particles are able to get into the bloodstream. And so whatever the toxin is, whatever the particulate matter is, it can affect you internally. It can cause anything from different cancers to any effects on your organs or your blood. It can get inside of your body, and a lot of times you wouldn't even think about air pollution actually causing these cancers, but it very well can. The bigger particles may cause more respiratory illnesses, so they'll stay in the lungs, but it'll tend to manifest more as just a respiratory illness, as it doesn't get through the alveoli in your lungs. So what is the air pollution like in our own state? Well, if you look at this, so this is where this information comes, it's from this link. We do not have any data collected so data not collected is what DNC stands for Winnebago County. And Wishart County is just west of us. They have no data collected as well. If you look at Outagamie County, so they give a letter grade of D, so A would be the best and D would be not so good, F is the worst. So Outagamie County is Appleton, just north of us. And if we look at Milwaukee, well, no surprises, Milwaukee gets an F. And this is, I should mention too, these numbers here are measuring for both ozone and for particulate matter, for different criteria of air pollution. And then for Fond du Lac County, just south of us, they get a D. And you might be surprised to see that Door County, which is kind of northeast of Green Bay, they get an F. A lot of people go to Door County because it's beautiful there and it seems so natural. But actually what happens is this air gets trapped between where Lake Michigan starts, the shoreline of Lake Michigan, and the prevailing winds that come from the west. And the air pollution actually follows up the coastline of Lake Michigan and ends up in Door County. So obviously no amount of air pollution is good for you, but the difficulty for regulatory standards is figuring out, well, how much can you handle, how much can people in general handle. And remember that different people are going to be susceptible to different kinds of air pollution. Some will be able to handle more than others just because of genetics. And then also people are exposed to different kinds of air pollution in their day-to-day lives. So it's gotta, you have to consider how much adds up between work and travel and home. So it's not easy to set the standards. Alright, so the diseases that are caused by indoor air and outdoor air pollution, well, here they are: asthma, pneumonia, tuberculosis, chronic bronchitis, various cancers, even cataracts with your eyes, different types of infections. And then for maternal situations, it is linked to low birth weights, and also it's especially in countries, Africa is famous for issues with indoor air pollution from cooking fires inside the home while pregnant. So this graph shows us, and this graph looks kind of messy, but look at the x-axis. It shows you the concentration of particulate matter of the size of 2.5 micrograms. And then we have the relative mortality rates on the y-axis. So the further to the right you go, the higher the air pollution, and the further up you go, the more people that die from air pollution. And it should be no surprise that you have a positive correlation here. If you look at the green dots, it shows you the time period from 1974 to 1989, and if you look at the blue dots, it shows you the time period from 1990 to 1998. And in general, you can see that from the green dots to the blue dots, that fewer people have died due to air pollution between these two time periods. So the question from the graph is asking you, what is the relative mortality rate for people from Steubenville, Ohio? We see that their mortality rate was 1.3. So if we look at Steubenville, Ohio, way up here, if you look across, their mortality rate was about 1.3. And then they used the control value of, hey, they picked a city from Wisconsin, Portage, Wisconsin, so about central Wisconsin. And so basically 1.3 means is that 1.3 more people died compared to the number of people that died from Portage, Wisconsin. And if you look at the concentration of particulate matter in Steubenville, Ohio, during that first time period, so they're asking you what was the concentration of particulate matter and what was the relative mortality rate. So you can look down, you can see that it was about 28 micrograms per meter squared, and the number of people that died was about 1.3 relative mortality. If you look at how much did each parameter change for Steubenville, Ohio, between the two time periods, so you look at the green dot for the first time period, the blue dot for the second time period, you can see that they had a reduction of about 1.08 mortality and then down to 22 micrograms per meter squared. So if you just subtract from the original values, you get 6 micrograms per meter squared, and the relative mortality rate fell by 0.22. So if you consider for every 100 people that died in Portage between 1990 and 1998 in the control city, how many died in Steubenville? Well, you would say that 108 people died in Steubenville compared to 100 people in Portage during that time period. Okay. The name of the U.S. agency that regulates and sets pollution standards, that would be the Environmental Protection Agency. So how do we deal with this problem? So in 1970, the EPA was formed, and they had regulated 6 criteria air pollutants at first. So this is kind of similar to when we learned about the criteria water pollutants with the Clean Water Act of 1972. So in 1970, there was the Clean Air Act. There was no conclusive evidence between pollution and human health, but they were following the precautionary principle and realizing that air pollution was definitely causing medical issues. Exactly what the problems were unclear. So like I said, they were following the precautionary principle. And here are the 6 air pollutants. There's also now 187 other air pollutants that are in addition to the original 6. And we also, like I've mentioned before, we now include carbon dioxide, which has only been included since I think it was 2007. Alright, the 6 criteria air pollutants. Particulate matter is number 1, and it can be in either air particles or in water droplets. And then 5 chemicals. The sulfur oxides, mostly coming from burning fossil fuels, in particular coal, carbon monoxide, nitrogen oxides, ground level ozone, and lead. And like I said, I'm going to be covering these more when we get to this table, which is on the next slide. So here they are, and then they have the other EPA regulated air pollutants. So recognizing volatile organic compounds, there's a wide range of volatile organic compounds. Many of these are causing, in many cases, indoor air pollution. So these would be like your solvents that you use in your home, like your cleaners and your markers and paints and paint thinners and anything that's going to release this kind of a, I always say it's kind of like a chemical smell. And then we also have mercury and carbon dioxide. Okay, so carbon monoxide. That can come from vehicles, forest fires, and volcanoes. It happens in any situation when there's a limited amount of oxygen when something is being burned. And carbon monoxide, that is, if you're breathing in too much carbon monoxide, that will take the place of oxygen in your bloodstream and will cause asphyxia. Sulfur dioxide, the release from any burning of fossil fuels, industry, volcanoes, and dust. It's a respiratory irritant. Remember, sulfur forms sulfuric acid, and sulfuric acid it will burn you, and it damages plants, aquatic creatures, and concrete structures as well. And we have nitrogen oxides. They're coming from again, mostly burning fossil fuels, vehicles, industry. A little bit of it is naturally occurring from nitrification from soil and aquatic bacteria. And again, it forms nitric acid, which is a respiratory irritant, but can also affect, very similarly to sulfur dioxide, affects plants and aquatic organisms and concrete structures. Also, there's the issue of over-fertilizing ecosystems and causing eutrophication. Ground level ozone. So what this is it's a secondary pollutant. So it is formed when nitrogen oxides and volatile organic compounds react with sunlight, and then ozone is formed. And ozone acts as a respiratory irritant, and it also affects photosynthesis in plants. Particulate matter is, like I've said, any kind of solid material that is able to float in the air. So it's generally any material that is less than 44 micrometers. So it can be released when there's any combustion of fossil fuels, or any fuels, wood as well, where dust is produced and is released into the air. And even sea spray is considered a type of particulate matter. Again, it's a respiratory irritant, and depending on how small it is, it can get into the bloodstream and affect you in many more ways than is initially apparent. Lead was a very bad problem back in the 1970s. We used to sell leaded gasoline that was supposed to help vehicles run better, supposed to stop knocking in engines, and also it was in paints and a lot of other materials that we use, but it has been officially banned in the United States since 1996. And anyway, lead is known to damage the nervous system, and as well as many other systems in the body. It's famous for affecting the mental development, the nervous system development of children. The volatile organic compounds, the solvents, paints, glues, other organic chemicals, and some VOCs are naturally released, but not in very high quantities. And they have a whole host of different effects that they can have depending on which volatile organic compound it is. And remember that volatile organic compounds will react with sunlight and form ozone as well. Mercury primarily comes from burning coal. I've mentioned before in class that coal is considered the kidneys of the earth, and coal has been sequestering different toxic compounds, especially toxic metals, for eons in the Earth's crust. And when we burn that coal, we are putting those compounds into the air, and mercury is one of them. And that's where this is the reason why we have fish consumption advisories for mercury, is primarily from our coal burning. But it also comes from mining and smelting operations, and naturally from forest fires and volcanoes. And I should mention that mercury is not as harmful when it's directly released as mercury, but what happens is there's a reaction that forms methylmercury, and that's the more dangerous form of mercury that can be sequestered in a body, in a person or an animal, and cause the most harm. But it is a neurotoxin, and it does affect the development of embryos. And then we have carbon dioxide, which we've talked about at length, burning any fossil fuels and forest fires. It's also part of normal decomposition. It's part of our normal respiration. Every time we breathe out, we're breathing out carbon dioxide, but the problem is that there is too much of it now. Okay, so is the greatest exposure to air pollution comes from being indoors. It depends on where you live, truthfully. It depends on, in developing countries, true would be the answer. And most people do live in developing countries, so the correct answer here is true. So, homes trap indoor air pollutants. So just like we talked about thermal inversions before, and you don't have to know how the thermal inversion exactly works, but just recognize that thermal inversions cause air pollution to be trapped, and that's very similar to what your home is doing. Your home is also trapping air pollutants in with you. And in developing countries, the air pollution mainly comes from indoor cooking fires. So in a house, if we think about where all the different sources of air pollution can come from, there's chlorine. That's your bleach. If you're using too much bleach, that can affect your lungs. You have particulates that come from your different gases in your home, as well as from fireplaces. Today they do sell very efficient fireplaces that greatly reduce the amount of particulates that come from them. Of course, you have pollen. You have the chemicals that are released from your furniture and other building materials. That conglomerate wood, that's the compressed wood that's glued together, that is said to offset a lot of VOCs from it. Tobacco, if you have indoor smoking, has over 3,000 chemicals in it. Then we have pesticides, cleaners, and anything that you're using, especially for cleaning and managing pests around your homes. And mildew. So mold and mildew are also a type of air pollutants. If they get pushed into the air, especially when they dry out and you're cleaning, they can get in the air and affect you. Dust mites can affect you, coming from, especially when you got the older carpeting. Any of those particles will get into the air. Paint will release volatile organic compounds. Carbon monoxide coming from a vehicle in a garage. If you have accidentally a situation where you're running a vehicle in the garage, or even if the door is open, sometimes the way the wind is blowing, it might trap the carbon monoxide in the garage. You have the particulates from cooking, the animal and hair dander, lawn chemicals that will be tracked inside on your shoes, and then in the basements. You may have heard of radon as being an issue, and there are test kits that you can use to test for radon, but radon is a radioactive air pollutant. Okay, so controlling air pollution. What are the policies that we use? Well, we need to use cleaner fuels. And by the way, there is no such thing as clean coal. We have better technologies today to clean fossil fuels, but you still have a toxin that you have to deal with. So even if less is going in the air, you still have to deal with the toxin after it's been removed from the fuel. So let's just look at ways to reduce air pollution. So using the cleaner fuels, and then also preventing its release. Alright, so this is the smokestack scrubber. It's a pretty simple premise that it's run on. What you've got are the emissions from burning coal, and you have misters. They're misting water, and what they do is they just trap those particles from the coal and carry the particles down to this basin with them. That's all it is. And then you have clean air that's released. And then you have the dirty water to deal with yet. And that's the problem. You still have to clean this water. You still have to deal with the toxin at the end of the day. It hasn't gone away. It's just not in the air, at least. We talked about cap and trade when we talked about carbon dioxide, but there's other cap and trade programs with other air pollutants. What that is D. The upper limit for pollution is set for each factory, but if one produces less, then they can sell the part of their allotment to another factory that produces too much. So there should be a review for you. So this is the illustration of it. It shows you two different industries. One is not producing as much carbon dioxide as it was allotted, and here's another industry that has produced too much carbon dioxide. So one of the problems with this is that in some areas where they're producing more, you're not going to have an even distribution of air pollution. So there's cap and trade, as illustrated here, but then there's also green taxes, where you pay for the amount of pollution that you produce, so in this case carbon dioxide, which we've talked about before. And we've also, this is very similar to the carbon fee and dividend, except for the dividend gets paid back to the consumer, to everybody. We also have subsidy programs, so you might qualify for a monetary payment if you produce less carbon dioxide or other air pollutant. And then also tax credits, so you may get more money, and this could be the dividend situation, where you would get extra money back on your taxes just based on what the carbon fee is, regardless of the amount of pollution that you put in the air yourself. So there's your two comparisons side by side. Here's a type of technology to reduce air pollution, and then a policy to reduce air pollution. So why control it through the government? Consider that it's mobile, it's moving, as we talked about. It's moving in the stratosphere, and so we might be producing the air pollution here. So what's our incentive to protect the air quality in another region, especially if it's another country? So remembering that pollution is transient, just like we've talked about water being transient, that it's constantly in motion. Alright, so considering convection and circulation, pollution is easily moved across the state and national boundaries. And we have health and economic costs. In 2003, there was a study that found that the average cost of an asthma patient per year was almost $5,000. And in the United States in 2007, the total cost was $56 billion. So also consider the effects on the ecosystem. They talk about how the salmon populations are in decline in relation to water acidity. So again, air pollution causes the acidification of natural water bodies. In this situation, what it does is it increases the aluminum in the water, which is toxic to fish. But what's the good news is due to regulation, our air is cleaner today than it was in the 1960s, and we have a even larger population and a larger economy than we had back in the 1960s. And this graph is not in your textbook, but it's one of my favorites. This is from the EPA, and it shows you how even while since 1980 our gross domestic product has increased, our economy has been growing, our vehicle miles traveled have increased, our population has increased, our energy consumption has, it did initially increase since the 1980, but it has actually been kind of dipping and fluctuating a little bit. And then along with that is our carbon dioxide emissions. And if you look at the 6 aggregate emissions, the 6 common pollutants in the study, it shows that meanwhile, while our population is growing, our economy is booming, and we're driving a lot, our aggregate emissions have actually been able to decrease over this time period. So in the study, the conclusion of the chapter, it talks about nailing down the exact causes of asthma, and the truth is it is caused by a lot of different things in different people. But what they found in this study, they're recognizing that air pollution affects the activity of genes, and it causes, if certain genes are turned off, then it actually it enhances the reaction to different particulate pollution and nitrogen oxide in the air, and it causes the immune system to go haywire. And also consider your chance of developing cancer increases with your exposure to polluted air. And this is also linked to your income. If you are lower income, you tend to be exposed to less polluted air and have less risk for developing cancer. So, overall, I think most people agree that we all deserve the same right to clean air. So this is called environmental justice. And the truth is that if you do the studies, you'll see that more low-income minority communities are suffering more consequences of air pollution. They have more air pollution and more health effects linked to air pollution. So what you can do to combat air pollution: you can, of course, check your house for radon. That would be something that if you ever purchase a new home and you've got a basement, you definitely want to check that out, especially in areas where radon is an issue. Using household cleaners that are safe to clean and regularly remove your pet hair and dander. So keep your house clean, and avoid cigarette smoking in your home. And we'll end this chapter with the quote, "What is there that is not a poison? All things are poison, and nothing without poison." Solely the dose determines a thing that is not poison. Alright, we will see you on Friday, and we'll move on to the next chapter.